BioVator is designed to withstand the harshest climate. This North American technology uses only top-grade products, including a stainless steel outer shell and optional stainless steel interior drum. It runs on regular 120-volt or 220-volt service, with typical installations using approximately $100 of electrical energy annually. The BioVator produces no harmful emissions, needs no other fuel source, and works using natural organic processes. It requires little maintenance, makes almost no noise, and looks more appealing than a dead stock bin. The drive system is designed to exceed the unit requirements and will function for years. Dead stock is turned into usable compost in as little as 14 days. A source of carbon such as broiler manure, wood chips, or rice hulls is then added. Paddles in the inside of the drum help turn the material as it rotates. An average rotation takes approximately 20 minutes. The temperature inside rises to around 140 degrees Fahrenheit or 60 Celsius. The slow rotation of the drum and paddles gradually moves the material toward the discharge end, and the end result is compost, ready for use as a fertilizer, bedding, or soil enhancer. The BioVator is reliable, easy to use, safe, secure, environmentally friendly, cost-effective.
PowerNot presents the LFC Biodigester, a food waste digester. It is an on-site solution for disposal of food waste. It has a clean and hygienic surface, free of latches and struts. Take care of food waste at its source. It uses a natural digestive process called aerobic digestion. Food waste, oxygen, and water are added to the machine. Aerobic digestion is done by microorganisms in an odorless process. Food waste is digested and converted to grey water. Arms paused 3/4 of the time to allow microorganisms to eat the waste. Output is grey water. Wastewater is discharged into the sewage system. View full history of LFC biodigester operations. Manufactured with stainless steel. Designed, developed, and manufactured in the USA.
Adfield Environmental Systems. Today we're going to be looking at the two machines behind me. Now, these machines both process the same types of waste. They're actually both the same primary chamber size, however, they are very, very different. One of these machines will last 3 to 4 times longer. One of these machines is more environmentally friendly, and one of these machines will save 40% on fuel every single time you use it. With incinerator machines like this, we have a secondary after chamber that cleans the gases. That secondary after chamber works at a temperature, a minimum of 850 degrees C for animal and 1100 degrees for medical machines. And all of the gases from the primary chamber have to stay in that chamber for a minimum of 2 seconds to ensure those gases have been cleaned effectively. At Adfield, we computer model all of our machines and we thermally model the flows through the systems. That enables us to ensure that the chambers are sized correctly before we go to manufacture, so we can actually prove the technology first. A higher cleaning capability compared to this machine. In fact, machines with undersized secondary chambers are more susceptible to creating smoke essentially. So looking at the steel thicknesses on our machine here, you can see we're using 10 mil thick plate. On the machine on my left hand side here, we're using 3 mil thick plate. And internally the materials are used a lot different as well, so we're using much thicker materials on the machine on the right side. So when we compare weights of these machines, the machine on my left here is about 800 kilograms, whereas this machine weighs 2.2 tons and has a lot more materials inside it. And it becomes really apparent when you're bashing these machines about in terms of the sounds they make. We choose to build machines that last. If we now look at efficiency of the machines, again, a very visual indication of machines, which is kind of difficult to see on the internet pages and brochures, is refractory thickness. So simply by measuring refractory thickness on the machines, you can see refractory thickness on the machine on my right hand side versus refractory thickness on my left hand side is completely different. And what does that mean to our customers? Well, a 40% fuel saving on the machine on my right here. So our external steel temperatures don't get hot, so our burners don't have to put so much fuel in to recover that lost energy. A 40% fuel saving shouldn't be sniffed at. Refractory thickness is really important, but so is the materials used. So with the machine on my left-hand side here, it's used a concrete lining. So to build a machine like that, it's very quick, it's very easy. You put a former in a steel case, you pour concrete in and you let it set, and it's pretty much done. We choose to use this refractory brickwork. So inside this machine there's 3 layers of insulation, and time-wise it's far more labour intensive to put each individual brick in place. So why on earth do we do it? In terms of efficiency, when we're heating this machine up to 600, 700, 800 degrees C, our concrete's against the steel, and as the concrete heats up, so will the steel. That will then radiate outwards, and again, it will create a very hot steel temperature.